So we'll work this last example on page 102, example 7. Same steps as example 6. So step 1, we need to move everything to one side. It has to have 0 on one side. So in order to do that, we're going to take this problem, the 2x over x plus 1, greater than or equal to 1, and we're going to subtract 1 on both sides. So that gives us 2x over x plus 1 minus, and we'll talk about this in just a second, and that's going to be greater than or equal to 0. So let's think about this 1. We can write 1 as 5 over 5 or 10 over 10. As long as the top and the bottom are the same, it's equal to 1. But we want the denominator to match the denominator of our other fraction. So we're going to have x plus 1 on the bottom. And if we want it to equal 1, that means we have to have x plus 1 on the top also. Now this allows us to do like what we talked about in class. We can write it as one fraction since it has a common denominator. We need to keep parentheses around it because we need to subtract the whole thing. So we'll distribute that negative, and that leaves us with 2x minus 1 over x plus 1 greater than or equal to 0. Combine these like terms, and we get x minus 1 over x plus 1 greater than or equal to 0. And this is what we'll use for the rest of the problem. So I'm going to write it at the top of my page so that we have it to look back at. So I'll stop and erase this step so we can move on to step 2. Okay, our step 2 is that we'll find our vertical asymptote. So we take x plus 1 and we make it equal 0. Subtract 1 from both sides and we get x equals negative 1. Step 3 is that we'll find a horizontal asymptote. And the degree on the top is 1. The degree on the bottom is 1. They're the same, so we use leading coefficients. And there's a 1 as our leading coefficient on the top and the bottom, so that gives me y equals 1. I'm going to have to erase this a little bit in order to have the ability to keep working, but I'll write the details up here in the corner of my page, and that way when we get ready to graph we'll have them. So step 4, is the x-intercept. So we'll take 0 and set it equal to this fraction. We're going to multiply both sides by the denominator to cancel it out. That gives us 0 is equal to x minus 1. We'll add 1 to both sides, and we get x equals 1. Remember, that's the point, 1, 0. Step 5 is the y-intercept. So we'll say y is equal to 0 minus 1 over 0 plus 1. That's negative 1 over positive 1, which gives us negative 1. And that's the point 0, negative 1. So now we're ready to graph. This line underneath tells us we're going to have solid lines when we graph. So let me get to a graphing page. Okay, now we're ready to graph. We have our vertical asymptote at x equals negative 1, so that's a dashed line at negative 1. Our horizontal asymptote's at y equals 1, so that's a dashed line right here. We have a point on our x-axis at 1, 0, and a point on our y-axis at 0, negative 1. So we have a curve, solid line curve that comes up through those 2 points. Now remember that vertical asymptote breaks this graph into 2 pieces. There's a piece on the left and a piece on the right. And we have the piece on the right, but we don't have our piece on the left. So we have to choose an x value that's somewhere to the left of our vertical asymptote. So I think I'll choose x equals -3. So I'm going to stick that into my equation. So I have -3 minus 1 over -3 plus 1. So it gives me -4 over -2, which tells me that y is 2. So that gives me the point -3, 2. I said -3, but I marked -4. So here's -3, and then up 2 is a point right there. So that gives me this curve here. Now remember that our original function was x minus 1 over x plus 1 greater than or equal to 0. So that means we want the parts of the curves that are above the x-axis. So this part of the curve right here is above the x-axis, this whole curve. So that means everything from the left of the vertical asymptote has the graph above the curve. So this would be -infinity to -1. Again, -1's not included because there's a dashed line at that vertical asymptote. Then right here, it starts above the x-axis. So this part right here is above the x-axis. That means from that point on to the right is above the x-axis. Now this curve is a solid line, so we'll have a bracket there starting at 1 and going to infinity. So we put these two together, and this is our solution.